Okay, so our next topic is line. As you can see, so we have a line is a locus of point with infinite distance from a fixed point. Okay, so we have several forms. We have the general form. Okay. General form ax plus by plus c, and then 2-point form, point slope form, slope intercept form, and then intercept form. We also have normal form. Okay, and then we have the properties of line. So for the line, okay, so we have the slope, which is m. It symbol of slope is usually m. M is equal to y2 minus y1 all over x2 minus x1. Okay, so the inclination of the line, if it inclines to right, it is positive, the slope is positive. Inclines to left, then the line is negative. I mean the slope of the line is negative. And then if it is a horizontal line, the slope is 0, and if it is a vertical line, the slope is infinity or undefined. And then we have, for the next one, we have parallel lines. Okay, so let's say that this is ax and then this is by. Let's say that the first line L1 is ax by plus c1, and then the next line is kax plus kby plus c2. So you can see they will only have a different c1 and c2. Their c will be different, but the a and b are the same. So the k indicates that you can, if you factor out a k here, okay, or any constant, the a's and b's, or the coefficients of their x and y's will be equal. The only different again is c1 and c2, and of course they are both equal to 0. And if the lines are said to be parallel, therefore their slopes are equal. So we can say that m1 is equal to m2. So parallel lines, they should look something like this. So these two are parallel. Okay, so you can say that those are parallel, or you can also say that these two are parallel as long as they are going into the same direction. They are parallel lines. Next, we have coincident line. So for the coincident line, they now have exactly the same. The only difference is you have to factor out the k first, and then they should have the same coefficients. Okay, so the coincident lines look something like this. So let's say that this is the first line L1, and then the coincident line will also be here. So that those two are coincident line. Okay, they are exactly on top of each other. So perpendicular lines, let's go to perpendicular lines. So if the first line is ax plus by plus c1, of course their c's are again different. The coefficients of x and y will be or change positions in the second line, and their signs will be different for the coefficient of y. Therefore, if you can see those relationship, therefore you can conclude that the lines are perpendicular. Then, if they're perpendicular, therefore the slopes of L1 and L2 are negative reciprocal, or simply M1 is equal to negative 1 over F2. That's it. Okay, do we have more? Yeah. Okay, so angle between two lines. To get the angle between two lines, you have to get their slope first. So that is tangent phi, or tangent theta, is equal to M2 difference of their slopes all over 1 plus M2 M1, their product of the slopes. So difference all over 1 plus product of their slopes. And all you have to do is just take the arctan of both sides, and then you'll have here arctan equal to the difference of slope all over 1 plus products of slope. So distance from a point to the line. So this is really easy. Let's say that you have here a given of a point of xo, and then yo, and you are asked to find the distance of this point into a line. So if you have a given line, all you have to do is just substitute the values of xo and yo to the values of x and y respectively. and then all over the square root of a squared plus b squared. That's it. Next, distance between parallel lines. Okay, distance between parallel lines. So you can see they must have a same a's and same b's, or same coefficients of x and y's. And the only difference for them is C2 and C1. So it will become D is equal to difference of their constants or their C's all over the square root of A plus B squared. Okay. Okay, so with that, let's proceed to some examples. Okay, so for number 1 of this topic, the line. So find the relation between Celsius and Fahrenheit, and at what reading when they are equal. Okay. So this will, as you can see, there are a couple of things that you should know here. So first of all, okay. So for number 1, you'll have here the freezing point, right? Freezing point, and then boiling point. Let's say of water. Okay? Most common is water. Okay? So for Celsius, the boiling or the freezing point for Celsius is 0, right? And then the boiling point is 100. Okay? So for Fahrenheit, how about for Fahrenheit? This is 32 and this is 21. That will be the boiling point in Fahrenheit. So what will happen here is, since the relationship is, or if you graph their findings, the 0 to 132 to 212, that is a line. Therefore, the C and the Fahrenheit will act as your X and Y. Okay, so your X will be C or the Celsius, and your Y will be the Fahrenheit. Therefore, if those are your variables, your 0 will be your x1 and this will be your y1, and then this will be your x2 and this will be your y2. That's it. And then as you can see, we have 2 points given, right? That's 2 points, therefore we can use this one. Okay, we can use this one. So using that one, you'll have, let's try to, so y minus y1, but your y here is Fahrenheit. Okay, so this will become f minus y1 is 32, equal to y2 minus y1, so 212 minus 32 all over x2 minus x1, which is 100 minus 0, times your x minus x1, your x here is C, minus x1 is 0. Okay, so let's try to simplify this one. You'll have your f minus 32 equal to 212 minus 32 over 100 minus 0. If you will simplify this, or you can use your calcu, this is just 9 over 5. That's 180. Yeah, that's 9 over 5. And C minus 0 is just C. Okay, so if I will now transpose 32, this equation will now be familiar with you, and it will show that you can see that this is now the formula when you are converting Fahrenheit or Celsius into Fahrenheit. Okay, and then the next one is we have to find and at what reading when they are equal. Okay, so if they are equal, therefore at C is equal to F, or Fahrenheit is equal to Celsius, then let's replace all the F with C. So you'll have here C is equal to 9 over 5, right? C plus 32. Okay, and then transpose, so C minus 9 over 5, C equal to 32. You'll have here factoring out C, therefore this will become 1 minus 9 over 5, okay, 32. And then when you solve for that, the Celsius will equal to negative 40 degrees. Okay, negative 40. So this will become also your Fahrenheit. Therefore, that only means that negative 40 Celsius is equal to negative 40 Fahrenheit. So that's it. Okay, so for number 2, we have find the equation of the perpendicular bisector of the line segment passing through 3, 2, and negative 2, negative 6. Okay, so let's draw a Cartesian plane. Okay, so we have 3 and 2. Let's say your 3 is here and then your 2 is here. So it should be here. This is the first point. And then negative 2, negative 6. So let's say this is negative 2 and then this is negative 6. So here. So collecting those two, the line will look like something like this. Okay. And okay. So this point is 3, 2. And then this one is negative 2, negative 6. So we are asked to find the equation of the perpendicular bisector of the line. Okay? So what you want, you need to know here is perpendicular bisector of the line. So if that is perpendicular, therefore, the line is, there are 90 degrees. The angle between them is 90 degrees. So the lines should be look like this. Okay. Therefore, this is the other line. Okay. And another thing is, it says here that bisector. When you say bisector, that is it divides the two, divides the line or anything into two equal parts. Therefore, if this is equal, so how long is this one? That will be the same length of this one. Therefore, if that is the case, therefore the perpendicular bisector, this point or their intersection will be your midpoint. That will be your midpoint. Okay. So let's try to get the midpoint first. So to get the midpoint M, so xm is equal to 1/2, right? The special case 1/2. So negative 2 plus 3. Okay, so this is 1/2. And then ym is equal to 1/2 again of 2 and 6. So 2 minus 6, right? So this is negative 4 over 2. So this is negative 2. Therefore, the midpoint is equal to 1/2 and negative 2. Now, we already have one point of the perpendicular bisector line. So, since they are perpendicular with each other, therefore, the relationship of their slope are also negative reciprocal. So, let's try to get the slope of the first one. So, let's say that m1 is equal to, m is equal to this is x2 minus x1, right? x2, let's say that's negative 2, and then minus 3. And then their y is, it should be y first, sorry. So y is, let's say, negative 6 minus 2. And then the lower one, let me just try to write the formulas. That's y2 minus y1 in order for you to don't get confused. So minus y1. So let's say that y2 is 2. How about, should I say 2? No, it should be negative 6. Okay? Negative 6 minus, and y1 is 2. Okay? And then the lower part will be their x. So negative 2 and then minus 3. Okay? So this will become negative 8 over negative 5, or 8 over 5. So to get since they are perpendicular, so the slope of the perpendicular bisector, which is perpendicular, it should be negative reciprocal. So it should be negative 5 over 8. Okay, so we already have the slope and the point. Therefore, we can use the point slope form, which is this one. That's y minus y1 equal to mx times y minus y1 equal to m times x minus x1. There, the y1 and x1 will be your midpoint. Okay, so applying that formula, therefore that will become y minus y1. Your y1 will be the midpoint, okay? Minus, this will become negative 2, right? Equal to the m, and your m is negative 5 over 8, negative 5 over 8, times x minus, but your x is 1 half. Okay. So all you have to do is just make this into a general equation. Okay, so this will become y plus 2 equal to negative 5 over 8 times x minus 1 half. How about we cross multiply the 8 and then distribute negative 5? That will become 8y plus 16 equal to negative 5x plus 5 over 2. Let's multiply everything by 2. So that 2 will be cancelled. So this is 16y plus 32 equal to negative 10x plus 5. Okay. And then let's transpose 10x. So 10x plus 16y. Negative 5 will be transposed. Plus 5 will be transposed. It will become negative. So this will become plus 27 equal to 0. And then this will be now the equation of the perpendicular bisector line. Okay, so we have now number 3. So find the distance from the origin to the line 4x plus 5y minus 20 equal to 0. Okay. So find the distance from the origin. So origin, of course, that is 0, 0. And the line is 4x plus 5y minus 20. So I already wrote it down here. So let's just make a divider. So distance, right? Distance. So distance of a line to a point. So we already have a formula for that. Distance of a line, this one. Distance from a point to the line. Okay? So all you have to do is just substitute the given x and y, or the given coordinate, to the equation of line all over the square root of their sum of their coefficients. Okay? So what you will do here is, so to get, let's say, d, okay. So to get that, you'll have 4x will be, so this will become your x and this is your y. Okay? So 4 times 0 plus 5 times 0 minus 2, okay, all over the square root of a squared, right? So 4 squared plus 5 squared. And if you will use your calculus, you'll get here 3.12. So this will be your answer. It's just a direct substitution. Very easy one. And then we have the next one. Find the distance between the lines 4x minus 3y negative 12 equal to 0 and 4x minus 3y plus y equal to 0. Okay. So for number 4, so we have two givens, okay, two lines. So we have 4x minus 3y minus 12 equal to 0, and then we have another one which is 4x minus 3y plus 8 equal to 0. Okay, so we have to find the distance between them. As you can see, if you by observation, their coefficients of x and the coefficients of y's are equal. Therefore, these two, we can immediately tell, or therefore conclude, that these two are parallel. Okay, they are in parallel because the only difference between them is their cis, or their constants. Okay, so we have to find the distance between parallel lines, right? And then going back to the formula, we have the distance between parallel lines, which is d is equal to the c2 minus c1 absolute value all over the a squared plus b squared. Okay. So the let's say that C2, okay, C2 is equal to 8, right? And then C1 is equal to negative. Therefore, and then therefore D is just equal to the difference of C2 minus C1. So that is 8 minus 12, right? Minus 12 all over to the square root of a squared, which is 4 squared, plus 3 squared. You can no longer write the negative 3 because it will be squared, and you can just neglect the signs because whatever you square, what number you square, it will become positive. So this is 3 squared. So this will become 20 over square root of, that's 16 plus 9, right? Become 20. So this will become 20 over 5, or equal to 4. So the distance between them is just 4. So I think that's the last problem for this topic. Let's move on to the next topic.